Hello everyone. In this video, we are going to see about Introduction to Polymers and Mechanism of Polymerization under Unit 1. In this video, we are going to learn about 1.1, that is the Introduction of Polymers. So this Unit 1 consists 5 subdivisions. First one, Polymer, then introductions, polymers introductions, classification of polymers, natural, synthetic, organic, inorganic, elastomers, fibers, resins, and thermoplastics and thermosetics. The 1.2 deals about the copolymers and its types of polymerization methods. Under 1.3, addition radical and ionic polymerization, coordination polymerization, step polymerization, polycondensation, polyaddition, and ring opening. Under 1.5, miscellaneous polymerization reactions, electrochemical, metathetical, group transfer. Among these 5 divisions, we are going to learn about the first division, introduction of polymers. A polymer is a high molecular weight compound formed by the repetition of small molecules called monomers, which are chemically bonded together. The word polymer is derived from the Greek word poly means many, mer means units. That means many units joined together to form a longer chain or bigger chain is called it as a polymers. So that polymer possesses high molecular weight compound. Polymers possess unique properties such as flexibility, strength, durability, lightweight, and chemical resistance. And also polymers are widely used in daily life, industry, medicine, textiles, electronics, and constructions. Those polymers used variety in their day-to-day life. For example, monomer, ethylene is called it, the single molecule of ethylene is called it as monomer. So polymer means the ethylene should be converted into polyethylene. How it should be converted? Number of monomers should be converted into polyethylene. The double bond will be break and the chain will be prolonged. That is called it as polymers. How the polymers are classified? Polymers can be classified based on the source, structure, composition, and properties. First one, based on the source. Based on the source, it should be classified natural polymers as well as synthetic polymers. First one is natural polymers. These polymers occur naturally in plants and animals. That polymers is called it as natural polymers. For example, cellulose, that means cotton, wood, these are the cellulose under cellulose category. Starch, proteins like silk, wool, natural rubber, DNA. These are some examples of natural polymers. This natural polymer should be used in the textiles, food materials, medicines, paper industry. Second, based on the source, we can classify in the synthetic polymers. These are man-made polymers. Synthetic polymers, otherwise called it as man-made polymers, by adding some chemical reactions or by adding some chemicals into the natural polymers, it should be converted into a synthetic polymers. For example, polyethylene, that is PE, PVC, that is polyvinyl chloride, polystyrene, nylon, Teflon. This synthetic polymer should be used in plastics, packaging materials like food, etc., electrical insulation, household goods. So these are the uses of synthetic polymers. Here some examples are given. So DNA, then rubber, cellulose, that means starch, cellulose, these wool, these plants from plants and animals, that is called it as a natural polymers. Synthetic polymers, that is man-made product, by adding some chemical reactions into that chemicals into that natural polymers, and it should be converted into a product that is called it as a synthetic or man-made product. So under this category, nylon, polyesters, Teflon, epoxy, these are the some examples of synthetic polymers. The second classification is polymers should be classified based on the chemical nature. From the chemical nature, of which should be classified organic polymers and inorganic polymers. First one is organic polymers. These polymers contain carbon atoms in their backbone. So carbon is the main backbone of these polymers. Examples: polyethylene, polystyrene, polyvinyl chloride, natural rubber. So this organic polymers possess a lightweight polymers. It should be a flexible one. It's good insulating properties. So this is a simple flow diagram for this organic polymers. So liver tissues. So it should be from this, it should be converted into tissues. Then from leaf tissues, then we have to prepare as a starch. In cell wall, that's like a cellulose. From this tissue, we can convert it into a glycogen. So these are the some organic examples of the organic polymers. The second classification is inorganic polymers. These polymers do not contain carbon in the main chain. But in case of organic polymers, carbon atom is the backbone of the structure. But in case of inorganic polymers, it doesn't contain carbon in a main chain. So for example, silicones and polyphosphines are the main two examples of the inorganic polymers. This inorganic polymer should use us in heat resistant materials, and also it is used for the lubricants in oils and sealants and electrical insulations. Then third category, it is the polymer should be classified based on the physical character. First one based on the source, second one based on the chemical nature, third one is based on the physical properties. So based on the physical properties, we can differentiate variety of polymers. First one is elastomers. What's the meaning of elastomers? Elastomers are polymers that show high elasticity and can return to their original shape after stretching. Once the polymer should be stretched out, and it should be, if you leave the stretching frequency, it again comes to the original shape. That means that polymer should possess high elasticity. It should be elongated. That is called it as elastomers. What are the characters of this elastomers is, it should be a soft and flexible, and also it should possess a low tensile strength and amorphous structure. The elastomers are a amorphous structure. So some of the examples of elastomers are natural rubber, neoprene, Buna rubber, Buna S rubber, Buna N. So these are the examples of natural rubber. That is elastomers. Okay, where this type of elastomer should be used means tires, rubber bands, seals, and gaskets. Okay, so see here there are some examples they have given how it should be prepared: constructions and automobile parts and medical part. Okay, so cylindrical needles, aerospace parts. In this area, the elastomer should be used. How it should be prepared? By applying polyesters and polyether. By combination of these two materials, elastomers polymer should be formed. That is copolymers. Co means combining of many polymers, two or more than two. That is copolymers. That by adding polyesters and polyether, it should be converted into elastomers. So based on the physical structure and physical properties, we can classify it as a fibers. What is the meaning of fibers? Fibers are polymers with high tensile strength and high modulus. It should be suitable for textile applications. This fiber should be used for the textile applications. That means the character should be much more better compared to the elastomers, that is strong intermolecular forces. It possesses high melting point and crystalline structure. So nylon 6X, polyesters, rayon, Kevlar are the some examples of the fibers. Where it should be used, these fibers are used in the clothing, that is textile industry, ropes and carpets. So these are some examples and also industrial fabrics. These are some examples. See, these are the corn fiber, coir fiber, then AFB fiber, flax fibers, hemp fiber, pineapple fiber, so jute fiber. These are some examples of the fibers. Then third classification is resins. Resins or polymers used as a binding or adhesive materials. It should be stick over on the wall, okay, or stick over on the paper, whatever it may be. It is binding or adhesive materials and are often odd and brittle. It is very odd and also it should be a brittle one. So what are the characters means? It should be rigid in structure, good chemical resistance. It can be thermoplastics or it may be thermosettings. So phenol formaldehyde resins, that is called it as a bakelite, and urea formaldehyde resin, epoxy resins, polyester resins are some examples of the resins. So what are the uses? It should be in case of adhesive and laminates and electrical components, paints and coatings. So this is the natural resins from the tree. So this liquid is called as a resins. Okay. So far we have seen that basic introduction of polymers. Once again, I recap what we have seen. So polymers, what is polymers? Poly means many, mer means units. So many units joined together to form a chain is called it as polymers. Okay. Then classification of polymers, it should be based on the source. It should be based on the chemical structure. It should be based on the physical properties. Based on the source, it should be natural polymer, synthetic polymer. Okay, so choose from the source, natural polymer, synthetic polymer. So natural, for example, natural polymers, cellulose, rubber. For synthetic polymers, the example is nylon, PVC. Based on the nature of polymers, it should be again subclassified into two types. One is organic polymers. The second one is inorganic polymers. Example of organic polymer is polyethylene. Inorganic polymers, example is silicones. So based on the properties, physical properties, it should be again subclassified into three steps. One is elastomers, fibers, resins. Elastomers, neoprene, fibers, nylon, resins, bakelite. Okay. So these are the, so far we have seen the 1.1 basic introductions of the polymers. Okay. So in next class, we'll go for the plastics, that is thermoplastics and thermosetics. Okay. So what is polymer? Poly means many, mer means units. Many units joined together to form a chain is called it as polymer. What are the classification? Natural, it should be form in the animals and plants. Synthetic, it should be a man-made. Organic, inorganic. Organic means that is main carbon atom is a main backbone of the structure. Inorganic, there is no backbone of the carbon atom. Elastomers, it should be in the elongation characters. Fibers, it should be in the case of hard and brittle. Resins, it should be from the adhesive properties. So far, we have seen the introduction and classification of polymers. Okay. Thank you all. We'll meet in the next video. Thank you.